Yes, my name is Seruyange and discussing artificial intelligence and intelligent systems. We are dealing with a systematic literature review of validation methods for artificial intelligence systems. This is the abstract. Artificial intelligence techniques such as machine learning have become prevalent in various domains, yet ensuring the trustworthiness of AI systems remains a critical challenge. This paper presents a systematic literature review that investigates the validation methods applied to practical AI systems. The objective is to classify and describe the methods used in realistic settings to ensure system dependability. Through the review of 90 papers analyzed AI systems across different domains, tasks, complexity levels, and validation methods employed. Introduction. The introduction of this paper provides an overview right? The introduction of this paper provides an overview of the importance and challenges of validating practical AI systems and applications. It highlights the increasing presence of AI in various domains and the need to establish trust in these systems. The paper acknowledges that while previous research has focused on machine learning, ML models, there is a lack of comprehensive work on validating AI systems as a whole. The authors define practical AI systems as complete systems that perform a purposeful function in a realistic context. The paper clarifies that it focuses on multi-component systems containing AI or simpler smart systems with clear implications of usability. The research method employed is a systematic literature review, SLR, which is considered an effective approach to gather knowledge about the current state of research. The organization of the paper is also outlined with sections dedicated to background and related work, research questions, methods, overview of selected papers, results, discussion, and conclusion. Previous work, AI systems and validation, background. The background section of the paper discusses the definitions of artificial intelligence and validation. Regarding validation, the authors refer to the IEE standard that defines validation as an activity ensuring that an end product meets the true needs and expectations of stakeholders. The authors point out the challenges in validating AI systems compared to traditional systems. The authors differentiate continuous validation, which arises from the special characteristics of AI systems. The section also highlights that the author's definition of validation is not strictly limited to ML model validation, which focuses on testing the generalization ability of a model. Related work. In the related work section, The paper highlights the challenges and deficiencies in validating AI-based systems as observed in previous research. The authors also address the deficiencies in supporting tools for validating AI systems. The section highlights the need for research on validation of AI systems due to their problematic nature and the difficulty of finding suitable solutions. Research questions. Research question 1. What kinds of practical AI systems and their characteristics are presented and validated in the research literature? The goal of this question is to explore the current state of research and identify the types of practical AI systems that have been studied and validated in the research literature. Research question 2. What kinds of validation methods are used with practical AI systems in the research literature? The goal of this question is to analyze and consolidate the available information on validation methods used with practical AI systems in the research literature. Research method, systematic literature review (SLR) approach by Kitchenham and Chatters in 2007. After the initial search, the authors applied 3 stages of paper selection to narrow down the retrieved papers, and these were inclusion criteria, exclusion criteria, and evidence assessment. Search strategy. The authors employed a systematic search strategy to gather initial set of papers for their review. To construct the search string, the authors combined terms related to artificial intelligence, and these were artificial intelligence, AI, machine learning, and many others. Paper selection. 372 papers were included based on their title, abstraction, and keywords using 2 inclusion criteria, IC1 and IC2. The remaining 372 papers were assessed based on the full text, and 142 papers were excluded using 7 exclusion criteria, EC1 to EC7. The final set of 90 papers was selected based on their relevance. Information extraction. The paper describes the process of data extraction from the selected papers using a data extraction form. The form consists of several fields, including basic bibliographic information, including author, title, year, then characteristics of the AI system under validation, domain task system complexity, system malfunction impact, validation method, continuous validation relevance score, rigor score, and machine learning utilization. The overview of the final papers includes information about their publication, sources, publication years, rigor scores, and relevance levels. Majority papers were published by IEE, 50 papers, followed by Elsevier, 15 papers, Springer published 11 papers, SEM 5 papers, and other publishers 9 papers. The publication years ranged from 2001 to 2020, with a median of 2017. The search covered the beginning of 2020, and a notable rise in the number of papers can be observed from 2012 onwards compared to preceding years. The characteristics of validated AI systems using research question 1. Quantitative statistics extracted from the papers are presented to provide insights into the characteristics of the systems. The most frequent domain represented in the papers was robotics with 21 papers. Recognition and classification were by far the most common. The papers presented a relatively even distribution across different levels of system complexity. 7. Validation methods. Research question 2. Occurrence, combined validation methods, continuous validation, popularity in different domains, trends over time, simulation variations, trial variations. Discussion. The authors provide an overview of the results obtained from their study on practical intelligent systems. Regarding the characteristics of validated systems in research question 1, the authors found a wide variety of systems reported in the literature, making it difficult to identify large common characteristics. For the second research question on validation methods, the authors extracted a taxonomy of validation methods from the papers. The authors noted that data-driven ML testing based on model-centered approaches is prone to data problems. Threats to validity, limited scope, limitations of automatic search, dominance of machine learning, limited evidence on continuous validation, potential bias, challenges in categorization. The conclusion discusses the main findings and contributions of a systematic literature review on the validation methods of AI systems. It discusses the scope of the literature review, the dominance of machine learning, taxonomy of validation methods, continuous validation methods, concerns and recommendations, authorship contributions. References include various members of the society who made reviews on various areas in artificial intelligence and machine learning. This page has 6 of them. The second page has 6 of them also, from 7 to 12. Then the last page also has 6 of them, 13 to 18. And that's the end.